friends, welcome back my YouTube channel MS Maths. In this video, we'll discuss the image of source, sink and doublet. In the previous video, we have discussed and we have derived the complex potential function for source, sink and doublet. So in the fluid dynamics, if there is any symmetrical radial flow which is producing from a point, this is called the source, and if it is radially inward to a point, then it is called the sink. And the doublet is basically the combination of the sink and source, okay, with the some distance or some small distance is delta as, it is called doublet. Okay, so the image is basically something, if there is a no flow in the fluid medium, then if it is a streamline in the flow and there is no, it's streamline in the fluid and there is no flow in the fluid, then if there is a sink or source or doublet is one side of the streamline, then the same in opposite side, it is opposite side of this surface, or basically it is the streamline, is called the image of the source, sink or doublet. Okay, so the definition is basically in a liquid S can be drawn across between there is no flow in any system of source, sink and doublet. There is no flow of the fluid, and on the opposite side of the surface is called the image of the system, that is basically the maybe source, sink or doublet, okay, with respect to the surface. Then that surface is basically the streamline in this case. Now image in 2D in a liquid sea can be drawn across between there is no flow, then any system of source, sink and doublet on the opposite side, its curve is known as the image of the system along the curve. See, basically if we have this is my x-axis and this is what y-axis, then this is a place. It means on x-axis there is a source of strength m, okay, and same there is a source on m's, and this is on strength m, and from origin the distance are same for these both. The coordinate for this is basically is minus a comma 0, and for this is a comma 0. I say this is my a point, and this is my a point and this is point b. This subtend the angle with x-axis with the green line, okay, this green line subtend the x angle with this, that is theta, and it is what, pi minus theta 1. Here it is theta 2, then this is what, pi minus theta 2. If it is a point P, okay, then if the point P is the image of the source, or basically it is the length r1 and it is, I say, length r2. If we will put this, or we will bring this here to here on the y-axis, I say this is the p dash. Okay, now we have the complex potential function of the sink, or of the source and sink. If we have this like source here, then the complex potential function is what, W is equals to 5 plus iota psi, and that is what for basically the source is minus of m log of z plus a. It means this is for this at minus a comma 0 coordinate, the equation is minus m log z plus a. For this it is minus m log z minus a. Okay, so we can write that this is what, minus of m log of z plus a, and into cos of, we can take minus common, it will be plus, and by the logarithmic property we can put into a multiplication, that is z minus a. Now we can just write what is this, so minus m log of, this is what, z plus a. So I can write it as r1 e to the power iota theta. Okay, what is z? Z is basically z can be written in the form of such a way that complex variable z is what, complex variable, z is here the complex variable. So the complex variable in a polar form, then z is equals to r e to the power iota theta, and z plus a is what, r1 e to the power iota theta, and z, this is what, r2 e to the power iota theta 2. This is with respect to theta 1. The length from this point is basically r1 and with the angle theta 1, and here it is r2 and with the angle theta 2. So we can just write and we can just simplify these both equations. So on simplifying, we'll get minus of m log r1 into r2 e to the power iota theta 1 plus theta 2 will be here. So we can just write in such a way that minus of m, because these both are in multiplication, so we can write it in as uh, addition. So it is minus of log r1 into r2, because there is a minus, then it is minus of iota log to the like e and log will be 1, then it is m of theta 1 plus theta 2. Okay, so this expression will here. So what is this? This is nothing but phi plus iota sine, and this is the complex potential function. So the stream function is sine, that is basically the minus of m theta 1 plus theta 2. Okay, this is what stream function. So the stream function is on imaginary line, because we have we have replaced this p on the imaginary axis. What is the y-axis in the like complex analysis? It is the imaginary axis. So we have taken here the imaginary part only. So this is what this imaginary, or this surface is basically in complex plane, or this basically in fluid. Yeah, in fluid, this surface is nothing but your if it is source. Yeah, if these both are source, sink, whatever it may be, so there is no flow across it. Okay, there is no flow across. So there is no flow, and this is what this imaginary line is called the stream line, because there is a stream function and which is constant. Stream function is what? It is a constant. It is a constant function. So if a stream function is your constant, then it is what? Stream line. That's a concept. If to get or to obtain the stream line, we'll put the stream function as constant, and to get the potential line, this is what? Potential function. So the potential function should be the constant, but here it is not constant. It is minus of m log r1 r2, and r1 r2 be the variable distances that may be changed with the a. Now, if theta 1 plus theta 2 is pi, then it will be obviously, it will be, yeah, it will be constant. Now, we have image of a line doublet in a plane. If we have a line doublet in such a way that if it is my x-axis and it is what? Imaginary axis, that is y-axis here. So whatever it may be, if I have, this is what the source is here, or basically the doublet, it means this is the combination of the sink and source. I say plus m, and this is my minus m. It means it is a minus, it is a sink and it is the source. It makes the angle with the x-axis is alpha, then whatever it is, pi minus alpha. The image of this at the same distance from here, it will be basically the in such a way that, yeah, if you will put a line to the mirror, it will work as a mirror, so you will get this type of image. Okay, the end part which is closer to the surface, and the image which has also the closer to the surface, the like which part is closer to the surface. Also the angle is same according to the reflection law, and this is also what? Pi minus alpha. So I say this is my AB, or we can say this is my A and B here, and this is what? A dash and B dash here. So this is what? Source, this is sink. I say this is my source and this is what? Sink. So it means this hole is doublet, or a line doublet, we can say. Doublet in line. Okay. Now, if a doublet in line, then how can we find? Consider the rigid plane x is equals to 0 and perpendicular to the plane flow xy plane. It means this is in flow in xy plane in such a way in the upper side of the plane. Okay. Thus, to determine the image of a line doublet with respect to the streamline OY, this is what your O, the streamline. This is what your streamline that we have earlier formed. Okay, this is what the stream line. Okay. The next, let there be line source at point A and B taken closer together to the strength minus m minus m or minus n per unit length. Okay. Let the strength of the source and sink is minus m and m. Now, next, their respective images in y, yeah, the sources at the strength minus m, yeah, their respective images oy are minus m at a dash, this is minus m at a dash, the same strength will be here also, so the strength for this is also plus m and minus m. In the image the strength will not be changed, it will be remain same, and are the reflections of the AB in OY plane. Okay, the line AB makes the angle alpha with OX, it means with x-axis, it means it makes alpha angle, and the A dash B dash makes angle with OX, the same angle will be here. And as m tending to infinity, as AB tending to 0, it means if I will take the strength tending to infinity, it means this strength will be such a large, so this, it means that the basically the distance between the A and B points will remain 0. It means the distance of AB remains 0. It means what? Whenever the strength will increase, then the distance the distance between the source and sink, or the, you can say the length of a doublet, will also decrease. Okay, will tending to 0. Then A and A dash be their axis inclined at alpha and pi minus alpha at x. This is what the concept. Whenever you will increase your strength, then these both will get closer to each other and AB tending to 0. This is the concept of the line doublet in the image, and the same thing will happen for the image also. Here the angle with x-axis is basically, you can say, if it is alpha, or you can say if it is, see, I can write in such a way that, see, if it is my alpha angle, if it is alpha angle, then it is what? If it is alpha angle, then it is also alpha. It is what? Pi minus alpha, and it is what? Pi minus alpha. So you can understand in such a way that the angle, there is alpha with this, and this is also the alpha. So this is what the concept. So I hope you are getting the point. What is the point of the image in the source, sink, and doublet in the fluid dynamics? So thanks for watching my video. Keep watching MS Maths, and for more video you can subscribe my channel, share my video to your friends, and thank you. Bye bye.